Okay, at this point, before we go to the next one, you want to may pause the video, uh, take a look at the next one. Uh, uh, Let me get over there. Take a look at the next one. Pretty similar, to what we've been doing. Has a single line, has a double line. Just take a maybe 10 minutes, look at this thing and see if you see where this 1.5 to 1 comes from. See if you see where this comes from. Compare this to this. These two, of course, will be the same. This is your single line. You got to come back, and this is a fill starting here. So things will be going in this direction. Excuse me, up to the center line. Now, do that if you want to, and come up with some questions as you're going through this. Uh, and you can email them to them, request it. We'll do another. We can do a big blue button and go back through this whole thing if you feel like you need it. And even if it's just one of you, that's fine. We can do this. This is really hard without demonstrating it. We'll be staking some of this once we get to the in person. Sometimes that helps. So, anyway, let's move on. But my suggestion is pause, check this out before I explain it, and if you want. So, it's talking about some examples. Where is it? The foregoing examples illustrate the two basic methods of writing slope stakes. As illustrated, there is a substantial difference in interpretation of the slope stake when a single line or double line is used. To ensure complete understanding of the two methods of writing slope stake, the following sample problem is presented. This is for you to do. Uh, and but I'm going to continue. I'm going to explain it, and then I want it wants you to do it. There'll be some graded exercises on down the road here, I think, but practice, practice, practice. So here we go. Let's go through it together. What? Here's the answer to figure 89. I'm not. Let me see if I'm not sure what they're saying when they say here's the answer for figure 89. Here's figure 89. Uh, the foregoing example, all these examples illustrate two basic methods of writing slope stakes. There's a substantial difference. Okay, so it's going to take us through the problem. I guess I'm just going to let me see what this says so I'm not missed. Slope information is always provided on an offset stake rather than a toe. Because the toe stake and the top stake's likely to get disturbed, run over. While no rule exists on how far out the offset should be from the toe or top, a 10-foot offset is considered normal. In other words, it's not showing an offset here, nor here, but here we were using offset stakes. Back to this little guy. Let me just go through it and see what they mean by example problem. We'll discover as we go along. Right now, we'll work this together. Here's your single line, here's your double line, and as always, they're going to be the same because things measured from this will be measured from this toe. This information will be on this toe. Now, you remember in slope staking, sometimes it tells you where to set your toe stake. This one's not doing that. Here's the toe. Here's the information. Field 3.3 at 2 to 1. There's your 2 to 1. There's your 3.3. Where did 6.6 come from? The vertical times the ratio. Let me just calculate. The vertical is 3.3 times the ratio 2 to 1, 2 equals 6.6. That's our horizontal. Let's go. Let's do it at the same time, like we've been doing. Let's look at the toe. At the double line state. Field 3, 3, 3 at 2 to 1 to the bench. That's the beginning of the bench. It's also a hinge point. But you see this right here, you know it's supposed to be level. So here it says field 3, 3 at 2 to 1 to bench. That took us here. Same thing here, took us here. Over here, it doesn't have an end in. It just says field 3, 3 at 16. Well, what's that going to do? Here is fill 3.3 at 16. Can we find 16? Right there. Okay, so if we start over here, and don't think of it as a slope, think of it as a point that from here horizontally is 16.6. There's 6.6. There's 10 is horizontally over to here and up 3.3. So see, that puts us here at 3.3, which makes this level. Let's see. There it is. It just says level. This one, once you got there, it just said level. This one did it mathematically by doing field 3.3, which is the same vertical, at 16.6, puts it in the same horizontal position. So both went to this point right here. It's good to think of these. They're making slopes. They're the connect the dots for a slope. But if you think of them as points in a profile, it helps you move, like over 10 and up. It does me. So we're here on both states. What's next? I can't go too far down. Fill 11.3 at 28.6. Let's see if we can figure up the 28.6. Here's 6.6. Here is what's that going to be? 17.6. Is that right? .6 and 17.6. That's going to be there. I'm thinking. Field 11 at 18.6, 16.6, and 12 plus 12 is, wait, I've got a mistake here. Let me start over. 6.6, 6.6 plus the 10 feet. That equals 16.6. Where did I get 7 there? That's 16.6. There's that, the horizontal. And it also says, it says fill. Where am I going? Excuse me. Let me start over. One more time. We've already done this. Fill 11.3 at 28.6. So this is 16.6, and 12 is 28.6. So from here to here is 28.6. That's our horizontal distance they're wanting there. And then it said from here, fill 11.3. Well, here's 3.3 right here, and here's 8. What is that? 11.3. So at 28.6 puts us here, and that 3.3 and 8 is our 11.3. So that puts us right here with the single line state. You can pause this anytime you want and think the band's going back and forth on me. Well, it is complicated just to sit here and talk and come up with these things. But we're going to move over. Let's check us out with the double line. So the level 10 foot put us here, as I recall. And then fill 8 foot, there's our 8, at 1.5 to 1. So what would be the horizontal? Would that be fill 8? It would be 12 right there. So 12 and 10 is the 16.6, and then this 6.6 puts us at 28.6, and the 8 and the 3.3 right here gives us our 11.3. So now all this gives us that. Let's go through this because I went, and then once we are here, this tells us to fill 8 at 1.5 to 1, which is 12. So that puts us at the same point. So both states have got us to this point. So the next one will probably be the center line, and this is going to be some scrolling back and forth. Let's do this one. Let's do the center line. Fill 11.6. Well, we see we're going higher by a bit. 3/10. That sounds familiar. But this is at 43.6. Let's see if we can come up with 43 on the horizontal. So the first horizontal is 6.6, 6.6 plus 10 plus 12. There is 28.6 plus 15. That equals 43.6. Look at there. It got us there. Now we got to see, can we get there with this 11.6? So let's go up here back to the state. And now we're looking for fills. There's 3.3 plus another 8 foot. 8. That gives us 11.3 plus another 3/10. I got 11.6. There it is. We got there with this stake. So here we are with this stake. We're here, and we need to be here. So once we're here, it's telling us fill 3/10. There's our 3/10 right there. Put us right there at 15 foot, right there to the center line. And does that give us 2%? 3/10 divided by 15? No, that gives us 2%. That's what we wanted. So we got there again. And pause, think about it, go back through it, write down your questions, refer to the figures that we're on, if we do have a big blue button, which I think maybe we should do that. I've already read about that. Here's a little simple deal. Now we're getting into the reference point to slope stake, where we would let's read this right quick, because we're getting into the real deal here. These were just samples of how to find these points. Accurate. I mean, we're going to do the same thing, but we're going to add a little dimension to it. I can see. So let's read this up here. Slope information is always provided on an offset stake rather than a toe or top stake, which is likely to get disturbed. We've already said it. While no, oh, we already read that. The reference point information contains the amount of vertical and horizontal distance relative to the slope stake. Figure 90, that's this figure right here, illustrates how to mark an offset stake. Well, let's see. According to figure 90, the top is 10 foot away. The top is 10 foot away, reference point to slope stake. I want you to put it in 10 feet, and I want it 1.2 higher than I am. And then, well, here's another way to do that. You can say it this way. This represents offset 10 foot, and it's assumed to be level. No, it's not assumed to be level. It's just assumed to be in 10 foot. That's saying the same thing. Fill 1.2. There's that plus 1.2. It wants this. This is your reference point. This is your top. It's wanting here. Is that going to help us? This is illustrating an instance. Well, yeah, okay. This is original ground. It wants it to be 0.2 higher than it is. Both these are doing the same thing, and they're written differently. They're both the same. I call them information stakes, but their reference point to slope stake or offset stake or information stake. They're telling you where to start. Here's the reference point, 10 foot out and up 1.2. That's where your top is going to be. According to figure 90, the top is always 10 foot. The top is 10 foot away. Therefore, the reference point is written in 10 and 2 followed by the slope stake data. Typically, in 10 are just 2 followed by the slope stake. According to figure 90, the top is 10 foot away and 1.2 above. 10 foot away and 1.2 above. Therefore, the RP is written in 10 or just 10. And I don't know what 2 means. It doesn't matter. Followed by the slope stake data. There's the slope stake data right there. I don't know. 1, it's followed by that, and 2, 1, it's written in 10, and 2, it's followed by the slope stake data, which is this data from here all the way down the stake. So, is this going to be continued? Let's see how I can do that. Let's look at this. Let's set our, this is 10 foot here. We're not talking about this anymore. We're talking about this right here. So in 10 foot, this is what I want you to do. I want you to set your top stake. I want it to be 8/10 lower than I am. Right there's the reference point. Here's your top stake for this slope, and it wants it to be 0.8 foot lower than it is. The hub would be down here. And we talk about that in slope staking, but we can talk about it again. But here's your double liner. And then I want you to cut 7 feet at 2:1. So here's the 7 at 2:1 gives us 14. So that puts us down here at the ditch or bench or hinge point down here. And then, or the toe as they're calling it down here. And then I want you to come back up. I want you to fill 6/10 because we made it here. And then it wants me to fill 6/10. That's a vertical of a tenth higher at 12 feet. And it's wanting to get a 5% fall. So let's take the vertical of 6/10, 0.6, and divide it by the horizontal of 12 equals 5%. Multiply that times 100 equals 5%. So that does take us, these two stakes take us to the center line. I mean, these two, this information and this information. But it does it by getting us starting at the reference point stake, going out 10 feet, and going down 8/10, and then from that 8/10 cutting, that puts us here, cutting 7 feet at 2 to 1, which puts us 7 down and 14 over this way to the toe of the slope. And then it wants us to go up 6/10 for 12 feet. And if we do that, we're going to get a 5% thing, because we've got to go up 6/10 over 12 feet. You take the 0.6 divided by 12, and you're going to get 0.05. Multiply that times 100, and you get 5%. So these two, this one got us here. This one got us here. And this one got us from here to here. Once again, this told us where to put our top. And then it told us where to put our toe. Cut 7 at 2 to 1, put it right here. And after you do that, I want you to fill 6/10 over 12 feet. And that's going to give me a 5% rise up to the center line, which gives me that cross slope I need to keep the water off the road. Okay. Not very complicated. Not very complicated. I don't know if do we have a next? It may be one I don't want. These you will find there will be some exercises. I want you to do the exercises first, and then you can go back and check yourself with these. These are answers of stakes we have not done. These are answers of stakes that you're going to do. But I'm going to hide them here from you and give you some time to work on this. And then we'll reveal them so you can check your work. And you'll see it. Like I won't call it cheating. If you get lost, you're welcome to come here, but I'd like for you to try to do what you will see will be exercise 1, exercise 2, and exercise 3 in your week 7 assignment. Let me get back to the regular modules. Here we go. We have we look quickly at an overview. That's where your answers for your assignment is. I'm telling you not to look at them until you do your assignment, and do your assignment in pencil, practicing. And if you're having trouble, I will reveal these before you're done with this, before this is due. So you can go back before week 7 is due. I think that will be, let me look on my little microscopic calendar here. The week 7 is going to be due on the 27th of February. Week 7 will be due. So you'll have a little time. I'm giving you guys this course a little extra day there. Instead of Sundays, I'm asking them to be in no later than Mondays. And if you go past Monday, I'm going to penalize you terribly. So here's what we've done. This is where I'm going to put this video. We've gone through the instructional material. Here's your answers And here is, there seems to be more. Uh, Slope stakes and reference point. There seems to be something else. No, these are the ones we did. These are the ones we did. Oh, I know what. I want to see the assignment ones. So let me see if I can sneak back to modules. We did it. So I'm going to give you a peek at the assignment. I'm asking you not to look for the answers for the assignments, but I'm going to give you, here's your week 7 assignment right here. Slope stakes and reference points. Ta-da. I rewrote these instructors earlier today. This is from the last presentation. I think I got it. So this is a real assignment that you're going to have. The following 3 practice exercises. Exercise 1 right here. It's a little crowded, but that's exercise 1, exercise 2, exercise 3. This is your test. The following 3, they're calling it practice, but I'm not, are provided for your benefit. On a sheet or sheets of paper, draw a stake for each exercise. And again, you see how we're drawing these stakes. You can go back and look. You draw them as if you're facing the stake so you can read and write on it. And you can freehand these, just make it legible. Take your time. And draw a stake for each exercise. Like this exercise right here, it doesn't have a stake. You're going to need to draw it. You're going to need to look at this, and I'll go over it with you a little bit. So take a clear photo, and that means I want to be able to read the stake, and then submit it with the file upload. You can use your phone, I'm thinking, and take a photo of it and get it to the there's a way to upload a file in your text box, and you'll see it. I can't see it. We can't see it right now. So exercise 1, write the reference, and notice here, give me a call if you get jammed up and don't even understand this, but and that's okay. This is new and difficult. Write the reference point to slope stake, and you may recall what that looks like. That's the stake that I call an information stake, but it's going to tell you, here's your reference point to slope stake. So what it's going to say is, I'm an RSP, what is it, RPSS, reference point to slope stake, in 10 feet, fill plus 1.2. Fill 1.2. Reference point to slope stake in 10 feet, fill, or just put plus 1.2, and that's telling you where to put your top stake. And then you will cut 4 at 3:1, or you can say, and then you will cut 12, you can cut 4 at 12 feet. That would give you 3:1. The next line would be, and then, I'm using all and thens on these so far. And then, see, we're right here, and then level at 15 feet. Right? Single line. Same thing at the top. Reference point to slope stake. Cut R, fill R plus 1.2, and then cut 4 at 12, or cut 4 at 3 to 1. So that would put you right here. Now, if you're using a single line, which I'd like for you to do at least once in here, you would say, to get this stake would say cut whatever this stake, this stake, all its stake would say would be level. So I'm not worried about that. If it's single line from here, I would be worried. So on a single line, you would cut 4 feet at 27 feet. You understand that? Because it was 12 feet to here from here, and I needed to be they're both the same level. You know, this was a cut of 4 from here going back to the original stake, and this was a cut of 4 going back to the original stake. This had a horizontal of 12. This, I asked for a horizontal of 27 because I had to get you to this point. And cut doesn't necessarily mean there's dirt there. It's just the way you get to that point where your bottom of your cut is, and then it gives you your horizontal. Let's do this one. Your reference point is here. So I'm asking you to fill in the reference point. So it's RPSS, or you can just put O/S, I don't care. RPSS in 20 feet. See, I want me to be way out of the way. In 20 feet, cut 0.9 feet. So on that top part of the stake, it would say RPSS in 20 feet, cut 0.9, R minus 0.9. And that puts you right here. And then you get to put and then you need to fill 15/6 either at 2 to 1 or whatever 2 to 1. What is the 2 to 1 here? Wait a minute. We want to get to this one first. Yes. We want to fill 15/6 at 2 to 1. So what does that do for this? What is this? 15/6 so that's the vertical. So it's the vertical times the horizontal. So if it's filled 15/6 at 2 to 1, it's 31.2. So it's filled 15/6 at 31.2. Go out here 31.2, fill 15/6. Now if I want to, I can say, and then fill, what's 2% over 20? 0.4. I can say fill 0.4 at 20, or I can say fill 0.4. I can say 2% at 20 feet. If I go back to here, I forgot this outrageous number. 2 times 15, 6. 31.2. I can go back here to get to here. I can say fill. What is the 2%? 0.4. I can fill 31.2. 15.6. 0.6 plus 0.4 equals. I can say fill. Wait, I subtracted. So if I want to go back with a single line, I need to get you. We got here, so I need to get you here to the center line, and that's not level. This is 4/10 higher. So if this is 15.6, I need to add 0.4 because 20 foot over 2% is going to give you an elevation of higher than this of 0.4. 0.02 times 20, 0.02 times 20 equals 0.4. So not only do I go 15.6, I have to add 0.4. That's 16. So it would be fill 16 feet. And that would give me over this. That would be higher enough. But what would the distance be? The distance would be I have to do this every time instead of writing it down. Would be that 31.2 plus 20 feet. 51.2. 51.2 to get right here. So it would be fill 15.6 plus 4, which is 16, at 51.2. And that would put me right there. So this last one would be a single line. If it wasn't, and then once you get here, you could just say, oh gosh, it's easy to do. Fill 2% at 20, or I would just do the calculation, fill 0.4 at 20 feet. That'd give you the 2% if you did an and then from here. But I'd like for you to try to calculate what this horizontal distance would be from here to here, and this vertical distance would be from here up to here. This looks a little complicated, but tell me in your mind right now, think about this. Is it a fill or is it a cut slope? Here's your hint. Here's where your reference point. Here's your toe. Toe tells you it's a fill. So reference point to slope stake would be fill 10.2. First it would be cut or minus 0.6 at 10 feet. In 10 feet minus 0.6, or in 10 cut 0.6 to set your toe stake. And then fill 10.2 at 2 to 1, or you could say fill 10.2 at 20.4. That's what that is at 20.4. Fill 10. That would give you a 2 to 1 slope. Now, and then if you from that point using double line, and then you would cut. What is 2%? at 10 feet. 0.02 times 10 equals, you could say cut 0.2 in 10 right here. Or you could say 2% at 10 feet. And it would give you this point here. And then, if you kept using and then, so to check yourselves, you can do this and then you would be calculating this one. This right here, we'd start from beginning. Whatever your elevation is, you got to get to here. So, and then fill 9.6 at 2 to 1, which is the same. 9.6 times 2 equals, which is the same as fill 9.6 in 19.2. Right here, 19.2. And then level at 10. I mean at 12. See, that's level at 0%. Now, if you wanted to get from here on a single line to here on a single line, you would have to say fill. There's 10.2. $10.2. What is this elevation right here? You don't need it, do you? You need this elevation. But to get this elevation, you need this elevation, which is 10.2 to here. But you got to take this out at some point. Let's say 10.2 to here, and then let's subtract that 2% fall, which is that 2%, which is 2/10? Yeah. So you would take this elevation minus 2/10 plus 9.6. So you take the first elevation, fill 10.2, 0.2 minus 0.2 plus 9.6 equals 19.6. That would get you right here. No. That would get you right here. And you got to add nothing level. That would get you to the same place. As far as dimensions, you need to go back and calculate this dimension. So to calculate that, we could, let me get a piece of paper. You can write down your horizontals, you can get them calculated and out of the way. This, if I'm going from here, and that's the most important one to get single lines, what is this dimension right here? Well, the vertical is 10.2 and it's a 2 to 1, so 10.2 times 2 equals, so that first one's 20.4. To get us to here, and I have to take this is to get us to here is 30.4, and this right here 9.8 times 2 to 1. So I got 34. And the 9.8 vertical, I'm pointing with my finger, I can't believe that. With 2 to 1 gives us this dimension. .8 times 2, 19.6. So that's B13.6. So that's 73.6 horizontally from here to here. And then you go back and review my calculations, because we have to go up and then we go down 2/10, and then we go up again and level. So one way to go down 2/10 would be to make this fill add 2/10 to it. So that'd be a fill of 10 right there. Fill of 10. But it wouldn't include getting this in there. You have to get that in there. But this fill right here would be a fill of 10 to get you to the same point on double line. Okay, if I keep talking and you're not able to ask me any questions, I'm going to cut this thing off. I'll get it posted as soon as it takes it a while to load, and then you have to go to YouTube with it and then bring it back down. But I'll get it up there today, and you can take it from there. And call me not every 5 minutes. Try your best to get these things done. And then I'll also open the answers to these exercises and see how well you did. We're going to grade, if there's such a thing, we're going to grade a little on the curve. This is a lot for online learning, but don't use that. I understand it. That's why I'm saying, but don't use that as an excuse, I don't have to do well. Do your best, do your best, and I'll be around to help. So that's that. I want to go back one more time, look at modules, and make sure I've covered everything. Look at the module. We went through the weekly assignment. That's the last thing we did right here. Went through that. Oh, there's a tailgate in there. There's a couple of videos, and I just want you to take time and watch it. These guys are doing 3D stuff out in a field site, and I want you to give me, I've listed, well, the heck with it. Here. I'm not going to show the video, but it's pretty cool, and you'll be able to find some relationship. I just said view the following videos and comment on any content that is familiar. There's 2 videos, so watch them both. See what you can gain from them, because you're going to hear them say some things that we've just said. Not asking you to figure out exactly what they're doing. They're going to kind of tell you what they're doing, but they're using GPS to calculate slopes, but you'll hear them revert back to these principles, even though they have GPS. Okay, that'll do it, guys. Appreciate your efforts.